Hello everyone, so today we're going to talk about what is a function, section 2.1 in our book. A function is defined as a relation that relates one x value with exactly one y value. So if we look at our first example here, we can see that our x value of 3 corresponds to exactly one y value of 4. Our x value of 1 corresponds to exactly one y value of 3, x value of 2 to 5. Our x value of negative 3 corresponds to a 4 over here, so the same as our x value of 3 here, but that's fine because our x values are different. So each x value has to correspond to exactly one y value. So here, since we have all different x values, they all correspond to exactly one y value. So this is a function. Let's look at the next example over here. Here I have an x value of 3 corresponding to a y value of 4. X value of 1 corresponding to a y value of 3. X value of 2 to a y value of 5. Okay, but here I have the same x value corresponding to different y values. So this is not a function. We call that just a relation. So I got a couple more examples up here. Here we have a graph of y equals x squared. This one is a function because if we remember back, a function of a graph, we can easily tell if a graph is a function just by doing the vertical line test. So here, no matter where I draw that vertical line, right, I'm always only going to hit exactly one point on the graph. That's how we know that's a function. This example of our graph, if I draw a vertical line, I can see that I'm hitting the graph at 2 points. Meaning this is not a function, right? It does not pass the vertical line test. So just a few basic examples of functions. So let's dive into our chapter a little bit more. They want us to evaluate this function at these points. So I'll start off f of 2. What that means is I take a 2 and plug it into this function everywhere I see an x. Right, so here they take their x. Everywhere you see an x, I'm going to plug in 2 now. So that means I get 2 squared minus 5. I'm going to put that in parentheses. So whatever I see here, I'm just going to put it in parentheses, especially when I'm squaring things that can make a big difference. So now I go through and solve. 2 squared is 4 minus 5 gives me negative 1. So my x value of 2 corresponds to a y value of negative 1. All right, let's evaluate when f equals negative 3. So now I just take my negative 3 and I plug in wherever I see an x in my original function. So that means I'm going to plug in negative 3 for x. So I get negative 3 squared minus 5. Negative 3 squared is going to be a positive 9, right? Negative times a negative is going to be a positive. So whenever I square a negative number, I'm going to get a positive number. So my x value of negative 3 gives me a y value of 4. All right, let's do f of a. Right, so just the letter a. So same thing, I'm going to take wherever I see an x, I'm just going to plug in an a. So that means I get a squared minus 5. Since I don't know what that variable a, I don't know what number that corresponds to, this is as far as I can go. So my answer would just be a squared minus 5 if I'm evaluating this function at a. Now let's evaluate this function. Move it over here to get a little more space. Let's evaluate this function at f of a minus b. So now wherever I see an x, I have to plug in this whole term here, a minus b. Okay, so a minus b squared is not just simply a squared minus b squared. A lot of us will make that mistake. So when I have a minus b squared, what that actually means is I have to take a minus b and multiply it by a minus b, and then carry down by minus 5. So now to figure out what a minus b times a minus b is, or a minus b squared, I have to distribute, or FOIL. So I get a squared minus ab minus ab, right? And since I'm multiplying, I'm allowed to put them in whatever order I want, so I'm going to keep them in the same order. And then negative b times negative b is negative times a negative, b squared minus 5. So if I combine like terms, f of a minus b, so if I plug a minus b in for x, I'm going to get a squared minus 2ab's. I'm combining these two middle terms here, plus b squared minus 5. I'm combining like terms, and squaring this term here should not be new to us. So maybe a little review there. Okay, so my overall answer, a squared minus 2ab plus b squared minus 5, if I plug in a minus b to my function. So now we're going to evaluate this function, which happens to be a piecewise function. So we may have seen piecewise functions before, but if not, this example should get us familiar with piecewise functions. So just like the previous example, I'm going to plug in negative 5 for x. So I want to do f of negative 5. What the piecewise function means is I plug in negative 5 in for x. So I've got two different ways I can evaluate this piecewise function. If x is less than or equal to 5, then I use this term. If x is greater than 5, well, then my y value is always just going to be 3. And I think as I go through the example, hopefully that makes a little more sense. So, f of negative 5. Since x is less than 5, right, because negative 5 is less than 5, I'm going to plug negative 5 into this top term here, x minus 2. So that means I get negative 5 minus 2, so I get a negative 7. So when I plug in negative 5 to this piecewise function, I get negative 7 out. So my y is negative 7. Let's try another one. F of 7. All right, well, my x value here, my x is greater than 5, right? Because 7 is greater than 5. So then I use this second term here of my piecewise function. So my y value is just 3. So every time my x is greater than 5, strictly greater than 5, I'm going to come out with a y value of 3. So let's try another one. F of 0. Right? 0 is less than 5. So I'm going to use the top term of my piecewise function. I'm going to plug 0 in for my x. Right? And whenever I plug it in, I'm going to use parentheses. So 0 minus 2 is negative 2. And one final example. F of 10. Right, so my x value is greater than 5, so I'm going to use the second term here of my piecewise function. So my y value is 3. Every time my x value is greater than 5, my y value is going to be 3. So piecewise function, not too bad when you realize what to do with where to plug in your x values. Next, I want us to find the domain and range of this function. So domain and range should not be new. Might need a little refresher. I think it's easiest to find the domain and range of functions through the graph. So I did this graph at Desmos.com, so all of you have access to that. You just type this into your browser, and it's real easy to make your graph. So I just typed in f of x equals 3x into Desmos, and I get this graph. So my domain is, what are my x values? So what are my x values on this graph? So they only want it to limit to -2 to 4. So -2 is right here, and 4 is 1, 2, 3, 4 right here. Okay, so from my x equaling -2 to a +4, we can see that there's no interruption in my graph, right? My graph is a straight line. So that means the domain of my function from x equals -2, from x is greater than or equal to -2 to x is less than 4, right? There's no interruption in my graph. So that means my domain goes from -2, because I'm equal to -2, right, to 4. However, we had a stipulation here that x has to be strictly less than 4. So since it's strictly less than 4, I never actually touch this point here when x equals 4, so I use a parentheses to define that. And since I actually do touch the graph at -2, I use a bracket to define that. Okay, so less than or equal to, I'm allowed to use a bracket because I actually touch the point -2. This one is strictly less than 4, so I never actually touch the point x equals 4. That's why I use the parentheses there. I never actually touch the point. They also want us to find our range. So our range are our y values. How high or how low did we get? Well, when x equals 4, we can see that it touches this point there. And when x equals -2, we can see that it touches this point there. So when x equals 4, it touches the point 12 on the y-axis, right? So that's my range. That's as high as my graph gets in between this interval. And as low as my graph gets in between that interval is -6. Okay, and just like before with our domain, I actually touch this point -6. So my range is going to include the point -6. However, since I'm not allowed to go all the way over to x equals 4, my range is going to be 12, but I never actually touch that point 12, because my x values have to be strictly less than 4. So I'll never actually reach the height of 12. I'll just get very, very close to 12, never actually touching it. So here I found my domain. My x values go from -2 to 4, except I don't quite touch 4. And my range are my y values, and that goes from -6, I actually touch -6, all the way up to 12, where I don't actually touch 12. Okay, so 11.9 would fall in that range. Right, so I would be able to touch 11.9 y value, never quite reaching 12. Let's do one more example. Find the domain of this function. So here they're just asking for the domain, just the x values of this function. So as I go from left to right, my x values, right? This line goes on forever this way, this line goes up, this line goes down, and this line goes on forever that way. So as I go from -infinity, right, really big negative numbers, as I go towards positive numbers, right, I'm good, I'm good, I'm good, something funky is happening at -5, right? It looks like my graph is just approaching -5, right, but it's never going to cross -5. Reason for that being, if I plug -5 into my function, I'm going to get a 0 in the denominator. 0 in the denominator, we know we're not allowed to divide by 0, so our function is undefined at -5. So when x equals -5, our function is undefined. But it looks like everywhere else, right, we're going to have a nice continuous line. So how do we denote the domain of that? Well, every value less than -5, so all the way to -infinity, very large negative numbers. Negative 1,000, negative 2,000. Very large negative numbers, right? I can go any number over here to the left. I'm gonna find it on this line. As I get closer and closer to negative 5, well, this line is going to get very high, but my x value is never going to touch negative 5. And we just learned in the previous example, if I'm never going to touch that number, I'm going to use a parentheses. All right, so I'm going to get very, very close to that number, but never touch negative 5. Right? I can use negative 5.1, negative 6. They're very close to negative 5, but I'm never going to touch negative 5. And also, I can never touch negative infinity, right? Because infinity never ends. So we use a parentheses every time we have negative infinity or positive infinity, because you can never actually touch infinity. It goes on forever. So the left-hand portion of my graph here goes from negative infinity and approaches negative 5 but never touches it. That's why we use the parentheses here. That is union, that is joined with. So whenever we have two parts of a domain and range, we use the union symbol. Well, on the right-hand side of this negative 5, looks like I'm good, I'm continuous. So I'm going to start at negative 5. I can't touch negative 5, that's why I'm using parentheses again. Right? This line's never going to reach, never going to cross negative 5. And as I go to very big positive numbers, I'm continuous now. So there's no other x value that's going to cause my graph to be undefined. So I can pick anything greater than negative 5, and my function will be defined. So my domain of the function, I start at any negative number I want, bigger than negative 5, and as I get to negative 5, my function becomes undefined at negative 5, resulting in a parentheses there at negative 5. I can't include negative 5. If I plug negative 5 into my function, it's going to be undefined. That's why I've chosen here negative 5 with a parentheses. Can never touch it. But there's also a second part to my function here, to my graph here. Right? There's the right-hand side of negative 5. And all of those values are fine as long as I do not plug negative 5 into my function. So I can't plug negative 5 into my function, but I can go and pick any number greater than negative 5, and my function will hold. So domain of this function, negative infinity to negative 5, joined with negative 5 to infinity. So now go ahead and do the example problems that follow in the PowerPoint, and we'll discuss them at the beginning of class tomorrow.